In 2025, the US government published more than 300,000 datasets. Datasets full of interesting information from commodities prices, government contracts, financial statements. Datasets in all shapes and sizes, from PDFs to structured tables and free-form text. Datasets that are hard to explore, datasets that are full of 1,000 different stories. Stories interesting to a leading financial news company. Financial Times is such a company. It employs more than 700 journalists around the world. So to enable them to deliver on an excellent reporting, FT embarked on an AI-enabled journey. This is how the Storyfinding team was created. Hi, my name is Ivan, and this right there is my colleague Zdravko, and we are part of this team where we try to find stories that otherwise would not be told. What exactly are we doing? We are working really closely with journalists to develop tools for them. We bring structure to unruly datasets, find connections between and within data sources, applying modern ML techniques to increase discoverability. And for all those tasks, Airflow is an invaluable resource. In the next couple of minutes, me and Zdravko will show you a bunch of our work, and at the end, we will wrap up with some highlights, potential future work, and hopefully some time for questions. So, Zdravko?
Thanks, Ivan. Hey, everyone. I'm Zdravko. First of all, thank you all for being here. The first use case we are going to present is related to UK Register of Members' Financial Interests. This is a data set containing financial interests held by the UK members of the Parliament. This includes sources of income, gifts, donations, shareholdings, and other benefits that might eventually affect their actions. The idea of the dataset is to promote transparency and accountability in public service. The problem is that the dataset is quite hard to process manually, consisting of 5, 6, 700 plus pages semi-structured PDF reports released every couple of weeks, leading to lack of aggregation capabilities and important insights missed. As a result, some investigations might take weeks of manual data processing, if even possible at all. So our goal here was to structure the data as much as possible, remove duplicates, enrich with some additional information, and make it easy to access and play with for reporters and journalists. And of course, here, some Airflow magic was the perfect solution. Let's deep dive a bit more how exactly we did it. Keep in mind that this is not the full DAC, but a simplified version with just the main steps. The first thing we do is to scrape the PDF reports we haven't processed yet. The second step, we make use of the structure of the data using traditional programming techniques. Here is one example of a single report and just one part of that report containing the financial items for a particular Parliament member. We can clearly see that there is some kind of a structure. So the first thing we do is to get the name of the MP and then the different categories inside. All the different financial items are split into different categories based on different criteria. Then we extract all the items within each category. One important thing to note here is the common item information we have within the employment and earnings category. We make sure we handle it by replicating this information to all the items below. And in this way, we can get rid of the additional nesting throughout the whole report. Lastly, we process each item line by line, and we split based on the column sign. This simple rule handles probably at least 80% of the whole information. Of course, there are some corner cases, but we handle them separately. With that, we finish the basic processing of the information. And here starts the more interesting part, our attempt to process and normalize both the structured and unstructured data. Here we apply various different methods, including some machine learning models. So for example, we have the miscellaneous category, where we have quite a lot of free text inside. In such cases, we apply entity extraction, and we extract different things like roles, names, organizations, company names, addresses, amounts. And amounts in particular are quite interesting because you can see some cases where the MP gave money instead of receiving some. So in case we manage to extract any amount, we run a classification model on top of the amount with some context around the amount in order to detect that. Otherwise, we can overcount quite a lot when doing different aggregations. For example, how much money a certain MP received at the end. Another important thing here is the fuzzy matching throughout the whole report. This includes company names, individual donor names, addresses again. Quite often one the very same name can be written in a couple of different ways, so we try to detect that. And quite related to all of that, one of the main Airflow questions we faced was whether to run the machine learning models within Airflow or outside Airflow, and how exactly. It's important to note here that within the FT, we execute Airflow within Kubernetes using the Airflow Kubernetes executor. This means that each pipeline step is executed as a separate Kubernetes task. So having that said, one of the main challenges were, first of all, the machine learning packages are usually quite big. Also, model snapshots are also quite big. And last but not least, some additional processing power is needed within the Airflow cluster. Fortunately, we came up with some ideas. The first one being to host the machine learning model somewhere else and just call it from Airflow. For a small team like ours, usually it's not worth the effort because, especially in the beginning, things are moving quite fast and we're experimenting with different models. The second option, to install the machine learning packages for the whole Airflow instance. Within the Financial Times, we have a single Airflow instance used in a multi-tenancy manner, so we didn't want to clutter the list of packages with some which are going to be used only by us. The third option, a Python virtual environment operator with cache enabled. It partially solves the problem because now we can cache the installation of the packages, but again, not the download step of the model snapshots. And last but not least, custom Docker image executed in Kubernetes spot operator with packages pre-installed and model snapshots downloaded beforehand. Yeah, it's a bit more extra work, but solves all the problems above, so we decided to go with this option. Here's the most important part of Docker file definition. Apart from the installation of the packages, we have a single step for downloading the model snapshots. And inside, based on the package we use for the model, we download the version we want. At the moment, Gliner is the model we use for the entity extraction, and the Bertha zero-shot classification is the model we use for classifying the amounts. With that, we wrap up the step of the processing of the data. The next step is to connect the UK register with other datasets as part of our connections analysis initiative. UK Companies House is one such dataset where you can find official company information for most of the UK-based companies. This includes some basic information like company name, address, but also filing history and people, where you can find company officers and also people with significant control, which might be extremely useful when doing some investigations how money flows across different companies and people. Lastly, we export the data in structured CSV format in Google Drive, so different reporters, which in most of the cases are not quite technical people, can use this information differently based on the current investigation they are working on. And you can ask, what can you do with this structured and enriched information? Here is one example for your story. The UK Prime Minister Keir Starmer was given thousands of pounds in a relatively short amount of time for attending different football games. And yeah, before I give the word back to my colleague and friend Ivan, things change. Unfortunately, a couple of months after we released the first version of our pipeline, the UK government decided to provide the data not only in PDF, but in CSV format as well, and also change completely how the website works. As a result, we needed to change at least 50% of our pipeline, but good news is that we still managed to keep huge amount of the code and enrich the data additionally on top.
So, Securities and Exchange Commission. In the United States, each publicly traded company is required to periodically publish markets-related information. So, how they're doing financially, do they expect any headwinds in the near future, or what they are paying CEOs this year. The data is usually provided in a semi-structured way. Some of it is machine readable, but the more interesting parts are free-form text. So every company publishes dozens of documents each year, some of which are more than 200 pages long. So it's a hard problem to follow what is happening with a specific company, let alone a whole industry. And we set out to help our journalists in this space. We wanted to provide a tool to help them spot trends quickly or uncover stories spanning multiple companies. So we decided to parse the data and build a simple RAG on top of it. And of course, we used Airflow for this. Let's look at one of the forms we are parsing. So this is the 10K. It's published once a year. The data in it is usually pretty long. It's organizational structure, financial statements, other relevant information. So it can be, yeah, big. It's provided in something called the XBRL format, which allows for different types of data, charts, graphics, text, tables, where the factual information, like the tables, the financial statements, is tagged and accessible through code. This is not the case for the text. For it, we need to apply a bit of processing ourselves. So what we do is we split the document into something we call sections. We use the table of contents for this. So business is one section, risk factor another, and so on. But some of the documents we are ingesting are missing their table of contents. So we rely on the battle-tested method of just throwing enough regular expressions at the problem until something happens. Okay, we are happy with our sections. Now we are starting something we call a chunking process. So summary, what are chunks? They are segments of the text bigger than a single sentence, smaller than the whole document. The upper bound is usually governed by a model down the pipeline of we are doing. So basically we use chunks to make large documents easier to work with, searchable, model friendly. Yeah, so after we have our document into sections, we go through the whole thing and just grab the text. We don't care right now about anything else. And we begin to create our chunks. We separate the text into sentences. For this, we use spacey language model. This is to ensure that the text is split linguistically correctly, so handling punctuation, abbreviation, those sorts of things. Also, I'm not sure. It looks good. When we are generating our chunks, we make sure that they overlap a bit. This is to ensure so we can reduce retrieval blind spots. So when you are making a query to the database later, if the relevant information is in the bounding region between chunks, we can surface it easily. And lastly, we check if the size of the chunk falls within the limit of our model. Here, I'm showing that we are loading the tokenizer for our embeddings model, just so that we can check that everything falls into space. Yeah, so we have our chunks, after which we start generating our vectors or embeddings. As you can see here, we are making an API call instead of loading another model like the others. And this comes down to what we learned from the UK register project and what Zdravko said previously. For small models with faster inferences, it's putting them into Airflow. It's quick and easy, pretty straightforward. But for large models that require more resources, basically starts to slow the whole pipeline down. So for us, putting the large models on a dedicated hardware, just calling them through an API is better. Plus, the bonus for us is that we are reusing the embeddings model that we use across FT, so we can plug in this project into other projects across the company. Yeah, lastly, we store the embeddings into a database and put a pretty front end on it for our journalists. So we found out that Streamlit is extremely helpful for this. So it requires almost no front-end knowledge, and just a couple of lines of code, you get a professional looking app. Lastly, when we needed to ingest lots of data previous years in order for this to be useful, we hit a couple of pitfalls. First, Airflow 2 has a built-in approach, but it requires COI 2. Good thing we heard that already solved in Airflow 3. Unfortunately, we have another issue. The DAG, the built-in approach uses the DAG schedule for creating the backfill runs, but our DAG runs every hour. So if we want to ingest 1 year of information, this would be almost 9,000 runs. And we want to ingest 20 years, so lots of runs. The last thing is, revenge of the regexes. The structure of the forms is pretty stable, but sometimes it fails. To parse something, meaning failed run. So after we fix and play with the regex, we need to start backfilling again. So this is not great. So to recap, we need a solution accessible through the UI. We can something that create small enough DAG runs with small enough intervals. So if something fails, it's not a big deal, but big enough intervals so that we don't wait to the death of the universe to ingest everything. And our solution is just add a custom DAG params for the start and end of the ingestion. And the bonus is you can add additionally some filtering for what you want to ingest and start manual runs and monitor them. As a result, our journalists can write stories like this one, where tech bosses spent millions more this year on personal security. And yeah, now to Zdravko with another dataset.
Last use case we're going to handle is regarding USA spending. This is a dataset containing information how US federal funds are spent across different agencies, recipients, and programs. The problem is that the dataset is quite large because of the amount of US government contracts and all the transactions related to them. As a result, usually it's quite hard to track what happens to a particular group of companies and how much money they receive. So what's the goal here? Here comes the difference compared to the previous two datasets. Here the idea is not really processing and structuring of the information, rather making sure reporters get notified when something interesting for them happens, and then they get an easy access to this subset of the data. And again, some Airflow magic, and a couple of pipelines later, we got the solution. The first pipeline is the data collection one, but this is not the interesting part. Here we just load some CSVs incrementally. What's more interesting is the notifications pipeline. So let's focus on it. Firstly, we parse the configuration per reporter or group of reporters. And probably you're asking where this configuration lives. We are proud to be using the Google Spreadsheet technology for that. So we have a single Google Spreadsheet file with a couple of tabs inside. Within the main one, for each group of entities, we have a single row where we have the name of the group and also a list of email addresses that should be notified when something happens. And then for each group, we have a separate tab where we have the actual list of entities together with their USA spending identifiers. Once we parse the configuration, we load it into Airflow XComs so the following task can access it and play with it afterwards. During the second step, we count the number of new transactions for each entity of interest based on the latest data we have collected. And in this way, we process only these entities where something really happened. Based on that, we export part of the new transactions. We then load them into Google Drive, where for each group we have a single Google Spreadsheet file with as much data as we could fit inside. And also we have the data in raw CSV format, so we can handle the case where the data was too much to fit into the spreadsheet file. Lastly, we send notifications email for each group of entities, but only in case something really happened with that particular group. We have a lot of things inside. For each entity of interest, we have the number of new transactions, we have some information where the data can be found, and we have some metadata regarding the number of rows. And yeah, you can see that quite often the Airflow XComs can be quite handy. As a result, we can enable stories like this, where the Trump administration cut off huge percentage on government spendings on consultants for some reason. And here our presentation ends, but it's just the start of our work since we are quite a new team. So make sure you follow us for more because we're working on some quite interesting stories and topics like election polls, geospatial, crypto, and much more.